Hey everyone, Wi-Fi 6, 6E, and now Wi-Fi 7 are all the rage in the wireless world these days. And believe it or not, people are already chattering about Wi-Fi 8. With growing demands for performance and reliability, tech companies are constantly pushing the envelope for their hardware and technology. Your hosts, Ali and Mark here, we're bringing you this very special episodes of Tower's Edge, MistFits Unmuted. Juniper Mist teams are doing an incredible job, and MistFits get to discuss and find out all about it. We just can't talk about it. Almost rhymes, right? But today we have been unmuted. I want to take this opportunity to thank the amazing folks from Juniper Mist and my fellow MistFits for joining and let them introduce themselves. So we'll start with Mark. I guess Mark, go for it.
You know me, Mark Houtz. I'm part of the Tower's Edge. I'm also a misfit, and I am grateful to Juniper.
Cool. I guess we'll just start with Ben.
Ben Shapiro. I'm Senior Network Engineer at Eugene School District 4J in Oregon, but I'm also the president of the Willamette Internet Exchange. So I'm all in on the packets.
Awesome. Alan?
Yeah, Alan Crow, Principal Engineer with Nexum. We're a Juniper VAR, and just means I get to play with a lot of Juniper for a lot of people and work on a lot of different types of networks.
Awesome. Kevin?
Yeah, Kevin McCartan, Senior IT Engineer at Musgrave Retail Partners Ireland.
Welcome. Bhavik?
Hi, my name is Bhavik Patel. I am a wireless product manager here at Mist. So yeah, I'm glad to be here among the known folks.
Thank you. Jonathan?
Ali, thank you. Jonathan Davis here, JD. I'm happy to be here. As you said, on the 19th of September, we at Juniper, we've announced our next Wi-Fi product, our new baby, and that, of course, is Wi-Fi 7. We are very excited about some of the features that come with the standard, like preamble puncturing, for example, and how that's going to affect our enterprise networking. However, like all things here at Juniper, we can't just announce an AP that meets the bare minimum of the standard. We really feel the need to take it several steps further because we care about meeting our customers where they are and kind of what they what they're doing in their organizations. And so we're excited about this, excited to be talking about it, and we appreciate Ali and Mark, you having us on.
Awesome. Thank you. So,
Welcome.
Wi-Fi 7, we have a short time, obviously, to talk about it. We obviously cannot get into every single detail. So I'm going to try to start with a couple of things that everyone seems to like and want to talk about. And that's MLO and preamble puncturing, right? As you mentioned, Jonathan. Curious, what is everyone's thoughts? You see the use case for either of these technologies out in whatever industry you work in, whether you're in a K-12, higher ed, or industrial manufacturing and retail. Would love to hear about from you guys.
Yeah, well, I guess if I want to step in first, in the retail world where we have it, if you look at what the retailers are trying to get, like when they see new tech, they want things that are going to either reduce costs for them or help them sell more product. So they're not necessarily looking at faster and better, but these new enhancements that are coming with Wi-Fi 7, like puncturing and multi-link operations, I think are going to be a huge benefit in retail. Having the ability to have multiple links, one single radio on the client, but listening on all links. So no matter what happens in the store, like there could be times when a new wall goes up, a new partition is thrown up, or there could be seasonal decorations. So important things like this, I think, is going to really benefit us.
When I walk into a mall, for example, right now, right, I walk into the retail stores, pretty much every retail store has an access point up there, right? And sometimes we're talking 80 megahertz channel widths, right? And all those access points, and they're just all stepping on each other. And I think that's where I can kind of see preamble puncturing and possibly MLO also making a difference, with regards to performance or whatever else is happening within the retail environment in each store.
Yeah, I suppose on that, like we're always We're always worried with the width of our channels. You know, we want to get the best coverage, but we don't want the interference. So a lot of times in retail, we just go, okay, just 20 megahertz because, you know, we can get a little bit further distance and interference is a little less. But with puncturing, you know, it allows us to kind of creep into those wider channels with the new bands. So yeah, I think it's massive.
Yeah, I think one more thing over there is if you look at in general the spectrum, right? If you're probably using something like a 40 megahertz channel or an 80 megahertz channel, right? 80 is amazing with 6 gigahertz. With 5 gig, we have seen a lot of situations where you just can't get rid of radar interference that might be around you. With 6, there is already a huge amount of incumbent space that exists around you. So taking this new spectrum into consideration and just making sure that anyone around you is not affected by it or you are not affected by them, and just having the preamble puncturing where you could take the first 40, but then the leftover 20 out of the 80 is still available to you is a huge value. I think that opens a lot of avenues.
Yeah, we see that a lot for our enterprise clients that are in multi-user buildings, right? So some of the towers we have in some of the larger metros and that where, you know, you open up your Wi-Fi list and it scrolls and scrolls and scrolls. That's where we really see, you know, preamble puncturing is going to become a nice feature for those so that they can just get some airspace, let alone, you know, a big channel, but being able to find some portion of airspace to get data through.
And that's an excellent point. Yeah, I remember walking into a building once, and it was a multi-tenant building and all that. Everyone literally was using 80 megahertz channels, right? And that can, yeah, it can definitely. And the fact that now we can use like preamble puncturing, right? Like I mean, that will definitely help us with regards to capacity and.
I mean, think about use cases where there are a lot of devices with not just work with enterprise gear, but they have their own SSIDs. I mean, think of the use cases like printers or maybe Chromecast and other devices which are not connected to the network. They still broadcast at SSID. They might be using 20 megahertz channel space out of the usability that you have. Now you can just circumvent those kind of nuanced SSIDs that are broadcasting in your environment and not care about them and still be able to utilize at least 60 out of the 80 that might be usable in that spectrum, right?
One example I have of that from K through 12 is we have a very heavy Apple ecosystem in our schools. And to mirror screens and project things onto the wall, Apple TVs are used along with Apple products. And the primary mode of that communication is a ad hoc point-to-point Wi-Fi network that's built over Bluetooth Discovery. So there's many other Wi-Fi networks operating in buildings that I don't have control of. That's where puncturing will be invaluable.
Yeah, we have a residential client, so it's a large tower of residences, and the local ISP put their routers in every single one of these units. And of course, they're turned on with both 2.4 and 5. So we had to design the network around, you know, providing them good 2.4 coverage all the way out to the edges of the residential spaces. And once the ISP came in and started lighting up all their modems, let alone all the residential printers and everything else, it's pretty crazy when you start doing some Wi-Fi scans of how just messy that space is. So we're hoping we can bring puncturing in and potentially give better coverage where needed.
Yeah.
So let me throw out a question here. I'm really curious to see how you guys are considering this. When we look at preamble puncturing, what we're really looking at is how do we make use of wider channels when we have that interference maybe somewhere inside of that channel. And from a client perspective, all of our management still continues to happen in that 20 megahertz channel. Our data flow is what's, our data transmission, the data frames are what's actually being transmitted at that 40 or 80 megahertz channel, for example. So how do you guys kind of overlay that knowledge into your designs? as far as choosing where you will or will not use preamble puncturing? Or maybe a better way of saying it is, where will you or will you not trust preamble puncturing?
I mean,
I think
I personally see it as a nice add-on to hopefully help enhance what RRM is already doing for us. So MIST's Radio Resource Management RRM has made our lives much easier when it comes to some of these polluted airspaces. But like Kevin has talked about, we've had to reduce channel size just to get good, reliable transmission. So my hope, and of course, some of this has to be proved out, right? We never trust it until it's done, but is to potentially be able to take the channel sizes up that one notch, and see if that gives us some better throughput when it comes to the actual data side of things. So trusting it, sure, but not until it's verified that it's actually working, because we all know a lot of this comes down to how the client handles it too, right? So now we've got to trust clients, and for any of us who have been doing Wi-Fi for a while, trusting a client is always a dangerous game. So it's kind of what we're looking at.
Yeah, I think my hope is for architecture wise, it's an add-on when it's needed, and I'm looking for RMM to make that suggestion. Like if RMM is constantly swapping channels in a confined space within a building, I would like a prompt from Marvis being like, hey, do you want to turn on preamble puncturing in this section of the building? That is how I see it working and how I hope it works.
I think that's where the Mist AI can kind of like come in, where it can see that, hey, all this is happening. Would you like to turn on preamble puncturing? I mean, I can see some kind of workflow along those lines happening. Maybe. I don't know.
I think the version that we are getting with the preamble puncturing with Wi-Fi 7 specifically is static preamble puncturing, which is essential to know that it's not dynamic. If your environment changes, it doesn't automatically adjust to it. I mean, it might be an iterative update in the coming versions of Wi-Fi, but in this version, what primarily adds value to it is definitely using the RIM to be able to identify those kind of intermittent interference that you might have, and then RRM just looking at it and saying, you know what, your so-and-so site has this channel not being utilized properly. So the RRM can constantly monitor it. Something similar to what radar systems have been doing, where these channels are affected. So previously you would not be able to take advantage of it. But now with this, because you are constantly learning your environment and you know that this is something that is affecting, when you're building the channel map itself, that's going to add value to it, at least in this update. And then hopefully we'll see improvements coming on top of it.
Bhavik, I imagine this creates a ton of additional complexity for RRM algorithms.
For sure. There's a lot of complexity that comes in with Wi-Fi 7. I think we talked about preamble puncturing a little bit. I think there are some functions which happen on the AP natively, which are very dynamic. And then there are functions which generally RRM takes into consideration, which are more over the time or historical learning. Static puncturing is one of those things. With MLO, we might have some of these learnings coming in. Again, that's very new, and I'm probably stepping on our coming topic. But the 6 gig itself being opened up, and the static power, the low power modes, and basically static puncturing is one more example. These are the very new nuances that Wi-Fi 7 brings, and I think this is probably one of the biggest change we'll see with our RRM algorithms in this version, for sure.
Jonathan, to one of your points, right? So another, I'm just going to extend on it a little bit, right? With regards to channel width. I mean, from the deployments that I do, I don't think I've ever, as far as I can tell, I don't see a need to ever use 80 megahertz channels, right? So that's another thing too. I mean, I'm kind of curious, what is everyone's thoughts? Like, you think even, yeah, we have a whole bunch of spectrum available in the US now. Do we see a need that we need to kind of up that to even more than 40 megahertz? I mean, sure we can, why not? But like,
It's 320 or nothing, man. Come on. 320.
go big or go home.
Exactly. If I can't use the entire channel width, what am I doing? No,
Yeah,
I definitely think that's important.
Yeah,
Yeah.
one of the challenges that I see, at least in my K through 12 organization, is COVID-19 and lockdowns that resulted in that, and remote learning that was a byproduct, was a catalyst for just technology explosion in the space. And we never got rid of those tools. They followed the students from their homes back into the schools, and none of the infrastructure was upgraded for it. So that's what I've been doing, at least in my tenure here. And one of the biggest challenges is MDM management of tens of thousands of devices anywhere at any time. The people managing these devices have no idea what they're doing beyond clicking a button to deploy. And sometimes they click all. And the struggle is having enough bandwidth and enough capacity in buildings to handle that. And that's the expectation. I want to click a button. I want them all to be updated instantly. And right now, the only thing I can say is you're limited by RF spectrum.
Okay, makes sense. Yeah, I mean, if you're trying to update a whole bunch of Apple iPads or Macs and all that kind of stuff, I can definitely see it and all that. At the same time, I can see it like, Ellen, to your point, right? I mean, ISPs, I mean, once they start deploying this, right? I mean, they're probably gonna, like you said, I mean, they're probably gonna be wanting to use 320 megahertz channels. It's totally possible, because that's what their marketing is gonna want to then advertise. Hey, you can get like these ridiculous, like, throughput or bandwidth, like using Wi-Fi 7 and all that, which means they're gonna be using those channels. So now imagine an MDU, right? Or space, and everyone's using 320 megahertz channel. That can get pretty crazy. I mean, how much preamble puncturing even at that point will help with the congested space like that, right? So we got to be nice, I guess, too, at the same time.
I think one of the weird parts of at least the ISP side, because I did work for a startup ISP doing fiber to the home, is everyone wanted like 1 gig or multi-gig WAN connectivity. But the kind of like dark side of that is that you're being throttled on the other end everywhere else on the internet. So do we need 320 when Netflix is going to bandwidth limit you at 25 megabits per second per client? I don't know. We're hitting that weird space of where the home now has more connectivity than the targets on the internet.
Yeah, absolutely. One more point I want to bring up is industrial use case, industrial manufacturing. I've done some work in there, not extensively, but I've done some work, and I can definitely see the MLO working out really well for, I mean, not just that, I mean, think warehousing also. I mean, Kevin, probably in retail, right? I mean, if you deal with the warehousing space, for example, imagine the handheld scanners or sensors, right, in the industrial setting, being able to establish multiple connections to different radios, and just because a lot of times, especially in the industrial space, that connectivity is very crucial. I mean, there's systems that are dependent on it. And I believe, Ellen, you work in healthcare a bunch, right? So, I mean, think medical devices. I mean, if they get upgraded, right? Because a lot of times there's a lot of old stuff in industrial and medical space. And if these devices can support this kind of connectivity, I mean, we can really provide some reliable connection and stability to these devices to transmit, patient data, or I don't know, whatever else, sensor data and that kind of stuff.
Yeah, I think that's one thing that brings reliability with that multi-link.
Yeah, if
exactly.
we can get them off at 2.4 for once, we might actually stand a chance of some reliability. And I think that's where I was going to say, the flip side of the high bandwidth is just that reliable connection regardless of the band, and being able to see them more dynamically jump between bands without a roaming event. As we get into that, that's where I really see some promise with MLO also.
Yeah, I don't think 2.4 is going away in this kind of stuff, though. Unfortunately, that's another thing too. But you know what? That then PML puncturing, I think, can come into play, because right now, I mean, imagine a sensor, an average sensor that is maybe sending, I don't know, a little bit data, like just a burst of data, right, that it needs to send. But every time it's doing a transmit or receive, it's taking up the whole 20 megahertz channel, right, in 2.4 gig, for example. With PML puncturing, possibly, I mean, that can shrink, and it can find space that is not being affected by something else, right? Because obviously in 2.4 we're talking a lot of interference, right, from different radios in that environment. So that can kind of benefit it, I think, in these kind of environments with regards to 2.4 gig.
Yeah,
So
especially as we look beyond what we get in 7, right? So we talk about looking towards 8, 9, our friend Peter's famous 10. As we start looking at some of these, I think where this technology and Wi-Fi 7 sets the foundation really gives us a great springboard to move forward too.
yeah, I
Yeah.
mean, if you think about the way Wi-Fi has evolved, right? I mean, there are certain standards certain improvements that came with standards, and which may not have panned out, but there are a lot of things which panned out and have been kept going. I mean, the first time MIMO was introduced for us, it was like, yeah, how is it going to work? I mean, you just had one transmitter, one receiver at that time, and today suddenly we see we are not just taking care or taking advantage of MIMO, but we have went much further. Um, so I think this Wi-Fi 7 brings in a foundation where, I mean, the initial clients that we are seeing are, even if they are maybe, so there are two sets of clients that we see in Wi-Fi 7 MLO specifically. There is what is known as multi-link single radio and then multi-link multi-radio. There are clients which operate in multi-link multi-radio today, but the lower end of the market is working on 2.4 and 5 or 2.4 and 6. So it's either 5 or 6 on the second radio that they are operating on. Um, as an as we have better signal improvement technologies where we can segregate 5 and 6 simultaneously transmit and receive, we see better clients, expensive clients, which can take 5 and 6 simultaneously, can transmit on 5 and receive on 6 or vice versa. And then that just gets drawn into the lower end of the market. So each and every device starts accepting. I mean, think of a world where we had to bring in the cards to put onto our laptops, and today even our Wi-Fi devices, our smart plugs, all of those devices are, I mean, printers and everything is basically smart connected, Wi-Fi connected. I mean, now it's like if something doesn't have Wi-Fi, it's like, should I really buy it? That's a question people ask. It's that kind of a thing where it will slowly get down into each and every device. And I think this foundation is huge.
Bhavik, you bring up a great point there, and maybe just for the sake of the Tower's Edge listeners, right? Because everyone kind of comes at this from a different angle. The thing to kind of clarify here is that MLO and Wi-Fi 7, as you said, it can be multi-radio, but it is not multi-AP, right? And I think that's kind of a misunderstanding I've seen in the past. I think, as we look forward, there's this dream, at least, right, that if we have multi-AP MLO, where we can be connected to, say, a 5 gigahertz radio on AP1 and a 6 gigahertz radio on AP2, that can significantly do things like improve roaming, right? That can significantly, ultimately, it truly allow us to have two complete authenticated connections and move from one to the other seamlessly. So that's really important. But it's important to understand right now we don't have that. So as going back to, I think what you said, Ali, what's more likely is roaming from say a 2.4 or a 5 or a 6 gigahertz radio to a 2.4, right? Where maybe we have that little better, we've got a little better SNR or a little better signal at the very least, as we maybe get towards a cell edge. So that's kind of the type of thing that we could potentially, if we think about roaming in MLO, that could be really interesting and useful. But I think that is, again, it's looking at where we are now, as you said, Bhavik, and where we could potentially take this. There's a lot of maybe additional things to consider between here and there, because obviously if we start addressing the same client across multiple access points, now that means we have multiple layer 2, single layer 2 address that we have to connect across multiple layer 2 connections, right? So then we start getting into a lot of weirdness, but that promise is out there for the future. But one thing I want to be really clear on is we're not there yet with MLO.
One
Go ahead.
One thing that Peter shared at the latest Juniper webinar about Wi-Fi 7, he shared a graphic that has actually really helped me understand MLO. It's this one. It's multi-link, single radio, multi-link, multi-radio. That's really what Bhavik was sharing. It really comes down to being able to talk to one radio on one AP, and then it's same radio on a same AP, or a different radio on the same AP, or using it for lower latency or higher throughput. That's the two benefits of this thing of MLO.
Yeah.
Go for it,
Jonathan, you brought up a really good point, and I'm thinking from the design perspective, right? I mean, normally what we've been designing for, a lot of times I designed just for 5 gig, right? Before 6 was out there and everything. A lot of times I was designing for 5 gig for all the production corporate devices that are important devices. Everything else, 2.4 or 5, right? Guest access, for example. But I'm thinking from the design perspective, now we're going to have to start also incorporating 2.4 gig also in there, and that can also help with the roaming also if that signal is reaching and going further possibly, and the device is associated to 6, 5, and 2.4, and as I'm walking away from the access point and my signal and 6 and 5 kind of starts to kind of go fade away, and I'm still connected, and then I'm still connected to 2.4, I'm not going to just drop and reconnect possibly. And it can possibly help with the roaming even between different access points as well, I'm thinking. So which means we're gonna have to rethink our design process also.
Well, I think we'll probably continue to design for 5 gigahertz or 6 gigahertz, because as you know, as long as you do a great design there, your 2.4 will be covered, right? If anything, you're going to be turning power down on your 2.4, just simply based on based on how far the signal goes, and things along those lines. A great 6 gigahertz design also ensures a great 5 gigahertz coverage and great 2.4 gig coverage. But because you do have that additional coverage per band as you work down, right? Yes, there's absolutely going to be those situations, especially in maybe the kind of a non-ideal design, right? I think that's when I think about Wi-Fi 7, I actually think that there will be probably better use cases for poorer designs, even though that's not what we want to see. I think with both MLO being able to transition to that 2.4 radio flawlessly, and also, as we were talking about earlier with preamble puncturing, people who run 80 megahertz channels, for example, or 160 megahertz channels, they are going to get benefits that they would not get previously. So in some ways, I think Wi-Fi 7 is going to help people who do horrible Wi-Fi, but it may also simply mask a problem that comes back to bite us. It'll be interesting to see how that works.
Yeah, as I say it, I only get to put the AP drops in once, so they're going to be dense, even if there isn't an AP connected to them now.
Sure.
Well, you could have dual 5 or dual 6 gig capability on your AP now. So you could actually switch your 2.4 off for the additional spectrum that you might have. Say 6 brings much more value in US because of the 1200 megahertz that's available now, versus the rest of the world, maybe you might have cleaner channels on 5. So now your RM should be able to be able to moderate 2.4 gig a little smarter.
Yeah, so normally like when I'm designing for 5 gig, I mean with missed access point, because I can do dual 5 gig. So normally instead of trying to do 40 megahertz, a lot of times I'll have multiple APs, but then I'll do 20 megahertz. So now one AP doing two 20 megahertz radios, that can kind of sometimes work out better than doing 140 megahertz, right? Channel. I want to get into the access point that missed access points for Wi-Fi 7. Before that, I'm gonna bug Mark real quick with regard, with the private LTE and everything, and all the cool benefits of private LTE with regards to QoS and how it can. I'm kind of curious. What are your thoughts with regards to now Wi-Fi 7 and maybe possibly taking care of some of the challenges, right? That we normally say, hey, private LTE can take care of those challenges. Like think AGVs, for example, right? And that kind of stuff. I'm just curious, what are your thoughts with regards to private LTE?
Absolutely. Private cellular has its place in certain locations, certain use cases. Wi-Fi 7 is actually stepping up. Wi-Fi is trying to step up and help with some of these issues. It is a contention-based protocol still. So you still have to play the CDS MCA game where you have to listen and wait for your time. Scheduling is fully not the same. In private cellular, it's very scheduled. Everything is all controlled by the radio. Wi-Fi 7 is trying to get there with OFDMA. 6 gigahertz is a lot farther along than 2.4 and 5 because of legacy clients. But we are heading in a world where we're trying to solve the same problems with both technologies. They still have their use cases. Wi-Fi 7 is not replacing cellular in all cases, and cellular is definitely not going to replace Wi-Fi. They're going to coexist together for specific use cases, but they're borrowing technologies from each other, like OFDMA and Wi-Fi 6, now Wi-Fi 7. Came from the cellular world. They've been using it for a long time. So we're following along. We're taking the best of both products and trying to create services that are best for everybody. So
cool. Excellent point. So I guess will it be Jonathan or Bhavik? Let's talk about the access point.
Let's let Bhavik do that. He knows this thing inside and out.
Sure.
Yeah, so we're excited about it. Mist is coming out with, I believe, 3 new models of an access point. So yeah, take it from here. Yeah, go for it.
So, just before I do that, I think one of the things that you were talking about was with regards to the 20 using the dual 5 on an AP, right? Basically. So just to add to it, right? MLO, most people do not realize that MLO is not just on different spectrums, but it can across. So EMLSR, which is Enhanced Multilink Single Radio, also basically helps you that if you just have a single radio and your client can listen on, say, channel 100 and channel 144, just as an example, right? It's still a 5 gig capable client, but if your AP can broadcast on 2 different channels and keep a MLO session established across those 2 channels, now your client can just switch across the 2 channel. If one of those becomes dirty, that brings a lot of value. That's some of the use cases that I think becomes common, and that's why we are seeing a lot of enhanced multilink single radio, where it may not be that expensive. It may be expensive to add a second radio and complications, but this still brings value. So just adding.
So you mean like if I have, I don't know, let's say one of the channel is in like, one of the DFS channels and one is like a non-DFS channel. I'm connected to both. And I don't know, one radio gets a DFS hits and client drops for whatever reason from that. I mean, because it has a second session, you mean like now I'm still connected to it, and I mean, there's no roaming technically happening. I mean, it's just a seamless.
So the way it works is the transmitter still makes a decision. but
Okay.
then the client is actively listening before a session starts. So a 2x2 laptop can have 1x1 across one channel and 1x1 across a second channel and keep listening. And when the AP says, hey, I'm going to transmit on channel 100, it's going to shift its 2x2 spatial streams to 100 and then start listening on it. When the session is ended, it's still listening on it. So now, instead of tearing down a session and re-establishing it on the same spectrum, you would now do a lowest latency use case with Wi-Fi 7, basically. A quad radio AP coming out. So we have a 4x4 AP that is operating on 2.4, 5, and 6. And we still have a 2x2 scan that can monitor your 2.4, 5, and 6. So you can make intelligent RRM decisions, monitor your network, have security functions, things like that. This AP can operate in 2.4, 5, and 6 with the tri-band scan. And then you could also have a dual 5 or a dual 6 combination. So now you could have this AP sort of a mix and match across your environment. So that's alternate APs can have dual 5 and alternate APs can have dual 6, and the third one can have maybe 2.4 combinations like that. It's a new opportunity for us with 6 gig thought through with Wi-Fi 7. With this, we are keeping our location IoT sensors as we have. The VBLE antenna array still exists on this AP, but we are also adding a second radio which can function for 802.15.4 functions like VBLE, Thread, Zigbee, or Matter. And then for the first time, we are also including UWB on our APs for location use cases, and then having a GPS sensor on this AP as well.
Okay, that's interesting. I mean, the with a dual 5 gig and dual 6, what you mentioned, I mean, that would be an interesting designing that way. I mean, obviously the tools that we use for designing, right? Some of the common tools that we use, Ekahau or Omina, for example, they're probably going to have to update a bunch in the back end, possibly. Well, I mean, I don't know. Not everyone uses the auto feature, right? So
yeah, I'm just giving an example where previously you had to decide where you are listening to maybe 3 APs at a time, and then one of them is 2.4, and then the second one is 5. But what do you do about the third one? Now you have a good use case to just spread it across your environment.
So one of the things I say, like whenever I'm working in Mist or whenever I'm doing a demo or a POC, like there's just so many options in the UI to accomplish everything, and I love that. Sometimes it's overwhelming because I can just accomplish everything in multiple different ways, right? So you're kind of, I feel like bringing the same thing to the AP. Now I can do a whole bunch of things that I want to do with the access point, right? And it can fit a whole bunch of different needs that I can see in different environments. Whether
We try to get everything on this AP. I mean, we try to make sure you have every option that you need. Just make the best use of it as much as you can. I think there's a lot of use cases that we'll explore as well. These are the kind of active feedback that we have been getting. With Wi-Fi 6E, 6 GHz was still fairly new. There were not many clients, but in some environments, we didn't talk about it, or rather, I didn't have my numbers shown, but in some environments, we are even seeing more than 50% or close to 50% 6 gig clients, which is huge. If we have that density spread across and more clients start supporting 6 gig, I think the value of having dual 5, dual 6 is extreme. Yeah. Any comments, anything to add that might have missed?
I'm curious about location and IoT stuff, and especially you adding like, the additional 15.4 radio, ultra wideband. I mean, that's very interesting. What are your thoughts? I mean, Kevin,
Yeah,
especially in your environment?
yeah, it flashed up for me. I mean, because in our environment and how it's always had to be for the last 6 or 7 years, is we would have to get additional Zigbee access points that are dotted around our store and are just another management platform for our retailers and the guys that manage it. So having this functionality now built into Mist, I'm sure there will be some integration then on Mist with some of these providers for things like shelf edge labels, so that we can interlink and have it all connected into one. Like it's nice the way that, like how Mist has done it now for the full stack of WAN edge, switch, and access point. I know the access point is now getting the full stack put on it too as well. It's very nice to see.
So that could, I mean, I'm thinking that can also decrease the cost of the additional cabling as well, right? Not just the hardware.
Yeah. So as I said, the management, but yeah, you're dead right. The cost as well. And as I said at the start, to retailers, reducing costs is a huge plus for them. So where we can provide that better.
Ali, too, if I can jump in here, I think the folks on here probably know this about me. Maybe some of your listeners don't. I love IoT, and I love it. All of the various protocols. And so I think one of the things that's interesting to call out here is when we say 802.15.4, that's kind of like saying 802.11, right? It is an IEEE standard that defines PHY and MAC. The MAC layer is kind of a little bit flexible. And we have the capabilities that of things that run on top, right? So Zigbee and Matter, we'll use those as examples. Zigbee has its own addressing, both from a layer 2 perspective and what we might think of as a layer 3 perspective. And then Matter runs actually on, well, Thread, I should say, runs on top of 6LoWPAN. So which is this IPv6 adaptation layer. So when we say we have a 15.4 radio and we specifically call out Thread, Zigbee, and Matter, what we're saying is we can choose which profile to support on top of that 15.4 radio. And this is really key because Kevin mentioned Zigbee, and Zigbee's been in the environment for a very long time. It certainly has a little bit of maturity. But if you actually go looking for what used to be called the Zigbee Alliance, what you'll find is that's now called the Connectivity Standards Alliance, which is responsible for Matter. So in many ways, Matter is what Wi-Fi was in the early 2000s. It's the kind of unifying standard that everyone's kind of getting around and going, here's this open standard, and we're all going to agree and work to it. And while it was initially kind of started for home use, there's a lot of enterprise use cases that are already, kind of building out for it. So with that 15.4 radio, Kevin, for example, can support Zigbee today, but as technology continues to advance and stores get upgraded and things along those lines, if there's a need to run that Thread 6LoWPAN Matter stack, that can also happen. And so that's really key for a lot of organizations that are kind of thinking about how do we support location awareness from an energy savings perspective, right? Especially with offices that may be only partially full, maybe completely empty on days. How do we verify when we need lighting, or how do we manage our lighting and our HVAC, for example? You don't have to make that choice right now. You can go with what you have if it's, say, Zigbee, and that you can then support Matter later on. And that's huge. The amount of wireless capabilities this thing has, it's a Swiss Army knife. It is amazing what they've managed to kind of build out here. And I'm super excited to see what this looks like in the enterprise space.
Yeah, I'm excited for building automation standardization. In many of our buildings, a lot of the access control and HVAC are still operating 10 megabit per second interfaces that do not play well with modern switches. And as we build new buildings, the amount of structured cabling runs we put in actually count against the sustainability rating of that building as it's being designed. So the more stuff we can push onto a wireless ecosystem, kind of the better at this point.
A lot of use cases definitely with that. Yep, but adding all those features in there. And there was next one, Novik, I believe that was
yes,
the physical interface actually.
Yep. I wanted to highlight this as this is the first time we are bringing in hitless PoE with our APs as well. Both of them are 10 gig. So now we have uplink power as well as uplink redundancy. So now you could operate both of them. So you could run two cables at once, and if you lose one, you still stay connected. Previously, our APs used to have downlink LAN port. We have changed that with being able to support uplink and PoE functions on the second port as well. So for those enterprises which are extremely conscious about redundancy so that their APs doesn't go down if one switch goes down, this is it.
So I can connect now, Ethernet 0, for example, to like switch number 1, and Ethernet 1 can go to switch number 2.
Right.
And it will hitless PoE. So I actually use that feature currently, and there's an excellent use case for it too. For example, I just want to make sure what will happen with that feature with regards to being able to forward traffic out Ethernet 1, for example, that is connected to a completely separate physical infrastructure for security reasons or compliance reasons. Does that feature still stay, and we can continue to use that feature?
So you can select which which one will be operational. Currently, the way it works is it will prefer E0, and then if E0 is not able to go outside, then we do perform tests, right? It monitors for whether it's getting active connection outside or not. So if E0 goes down, then we basically rely on E1, but eventually either using API or UI, you should be able to configure if you almost always want E1 to be the primary or vice versa in your configuration.
Okay, so I was thinking more along the lines of the custom forwarding feature, right? Like, so right now, sometimes I have a need where I'm forwarding one SSID and doing a custom forwarding to ETH1 that is connected to a separate switch and a completely separate firewall. Does that make sense?
I wouldn't recommend it, but but the scenario today is you do have different VLANs being mapped to different infrastructure that can operate. There might be some complications regarding it, but I mean, you in a typical scenario, basically we are endorsing redundancy for the functions.
Okay, we'll just have to see once the AP is out in our hands, right, to see how that operates. So what about the models? How many models are we talking? And okay, so
we have 3 AP models coming in. We have the integrated Omni antenna. So it's very much similar to the current AP45 we have, just a little bit bigger. Then we brought in integrated directional antenna model as well. Seems like a lot of people have directional antenna for that added coverage. That's the most common use case. So we added that in. And then if you have any custom antennas that you want to bring in, then we have an external antenna coming as well, antenna model, which is coming as well.
okay, and what's the beam width of the directional antenna?
That is 60 by 60.
60 by 60. Okay, that's cool. Any IP 68 models by any chance?
Can you repeat that one more time?
IP68 models, Hazmat, C1D2. I know IP61, for example. I'm assuming no, but just kind of figured, let me ask for the sake of asking.
How weather hardened is it?
This is an AP, this is an indoor AP model. So I can tell you that it's AP47 is not rated for it.
Okay.
For now.
Okay, cool.
We might
I'm
have
hearing
a
a Ziploc
future
bag.
conversation about some other product, but that's not what we're talking about now.
Exactly.
All right, that's awesome. Well, I guess we're hitting the end of this, and I just want to thank. We went over a whole bunch of different things, different use cases. Excited about the new AP47s that are coming out from Mist. I'm excited about seeing it in the UI and how it's going to actually present all the new. We're looking forward to seeing how how Mist is going to present this new data, right? I mean, one client connecting to multiple different radios, how that's going to look like, how the dynamic PCAP, for example, how that will work. So looking forward to kind of what you come out with. I'm sure it's going to be amazing as always. I'm gonna take a quick opportunity over here to thank Jonathan, Bhavik, and everyone else from other Misfits to join this. We'll see you next time. Thank you.
Thanks all.
Thank you,
You're welcome.
Ollie. Thank you.
Yeah, Ali.
Thank you, everyone.